This project is an RPG, a role-playing game. And of all the projects that I'm going to post and have posted, if you do any of them, I recommend that you do this one. This will be the biggest one and the longest one. Just the back end and the console, for the example, I coded was 3,500 lines of code. Okay? But the reason I recommend this one and that you commit to it might take you a while, might take you weeks or more than a month, depends on what you put into it. But if you commit to it and if you do it, you will literally apply every single thing we have talked about in every single video up until this point. I mean, this project covers it all. It reviews it all in a kinesthetic, hands-on way. You will put into practice data types, typecasting, operators, comparisons, decision structures, repetition structures, arrays, one-dimensional, two-dimensional arrays, classes, an inheritance hierarchy, encapsulation, derived classes, overriding and overloading, which we talked about. You will implement several different types of file access, which we talked about. I mean, literally, you will apply everything that we've talked about if you do this project, if you commit to it. It's up to you, but now we're going to start and we're going to do the back end first. We're going to focus on the console. That's where the important code is. That's where the logic is. When we're done with the back end, we can always go and add the front end. That's the easiest part, okay? The easiest part to code is the front end, because there are graphical design GUI tools out there that help you design a form, and then you can just go in and customize the code, which is what I did here. I used Posh GUI, and I designed a GUI for my form, and then I did have to go in and modify the code a lot. I did have to make a lot of changes and additions and edits and things, but it was a big help in terms of designing it. And it only took me basically a few hours to come up with a GUI for this game. And it, we're using sound, so we're going to use a sound player object and play sounds, and we're going to show some images and things. And so when I run the GUI, here's what it looks like. Alright, and then it loads this image, a little wolf here, and main output text will display here a long, long time ago in a galaxy far, far away. It was a dark and stormy night. And we're going to give the player inventory for inventory items that they have found. We're going to give them magic abilities that they can use. We'll display player stats, a use button for inventory items, an attack and defend button, a look button and a go button, and a load game and save game. And also, they can toggle back and forth using these radio buttons for a view mode. So if they click go, plays a sound, and we're just loading a JPEG here. It's just a map image. But eventually we could also do some vector graphics there. Maybe draw something over the top of that as they move through the map, just to show them where they are in the map. And then it will display in the main output text box, a night in the darkness 3.0, you awake from what appears to be a disturbing dream, knowing neither where you've been nor how you got where you are now. You slowly rise to your feet, bewildered and almost oblivious to the throbbing ache pulsating between your ringing ears. The air surrounding you feels cold and damp. As you open your eyes and they grow accustomed to the darkness, you find yourself standing on a flowing grassy knoll amidst dark green hills, towering stone fortresses and distant villages that somewhat resemble the feudal townships and castles of medieval Scotland. In the skies above, dark gray clouds are passing in billowing, wispy tendrils. They randomly shapeshift into obscure patterns. As you gaze towards the horizon to the north, you see a storm approaching from the east. A few black ravens fly over your head towards some unknown destination, their cries echoing softly against the creeping shadows. Okay, so just a GUI form there for the console game that we're gonna work on. And I will go over this too. Eventually, as I have time, I'll make another series of videos dealing with all of these graphical components, text boxes, radio buttons, Windows forms. This is actually pretty easy. I think you'll acquire this fairly quickly, how to use these objects to create graphical user interfaces, show dialogue. But that's another series of videos. What we want to focus on right now is applying all of the PowerShell that we have learned, okay? And then we can go back and build our graphical user interfaces later. For instance, here's one for a blackjack game.
Welcome to Casino Angelique.
And here's one for an Active Directory tool that I wrote to use at work, just to check user accounts for errors. And it's just a graphical interface that it basically displays all the bits and pieces of a user account that we have in Active Directory at work. And it helps us track down errors and things in an account. So, guys, you can always create a GUI, a graphical user interface for your app, after you've coded the backend. But the meat and potatoes, the core of your application, your script, your program is always the backend. The front end is just icing on the cake, right? It's just gravy. So you really kind of do that last. But in these examples, we're focusing on the console. And I'll do another series of videos later where we focus on implementing GUIs, graphical interfaces, with our applications. When you build a larger project, using classes and class type structures, where you have a parent or base class abstract data type, and you have lots of child objects that derive from, inherit from that parent class, you kind of want to start out designing your class hierarchy first, and set up your inheritance first. And then once you get your objects, remember a class is a blueprint for objects, or it's code that represents a real object in the real world, both what an object is, its attributes, and what it does, its methods. So once you get all of that coded and your classes are set, then you want to go through and create functions to build objects from those class definitions and use them in your program. Okay, so to start out with, in this example, we have some globals, right? These are constants, and they're also globals, but these are things that I need to use in the game. They need to get passed around from one function to another, and they need to persist in memory for different things that I'm doing, whether it's loading a character object from a file, or loading the game state from a file, or saving the game state to a file, or the character object. Okay, so max damage, bow staff damage, just damages for all the weapons. All of these are just numerical integer, basically constants, but also globals. Okay, and remember that a global always has the keyword global in front of it in PowerShell. Now these guys here, these are just constants, and I use this for location tracking. Later on, I write a function called SwitchBoard, and I use that to allow the player to navigate through the map in my game, so they can walk from one room to another in the dungeon, so to speak. Center 1 to North 1 to North 2, or go back south again, and so forth. So that's all these are right here. They're integer values, but I used them as constants along with that function that we'll take a look at later called SwitchBoard to control the navigation in the game for the player. Okay. These are weapons and just inventory items that a player can find and possess, and magic abilities that a player can acquire if they find different scrolls after defeating different enemies. They slowly grow and they kind of level up, and they gain new magic abilities as they defeat enemies and so forth. Armor, and they can find chainmail, which will give them, add an additional 5 points to their defense, or plate mail, which will add an additional 10 points to their defense. Global location, which I use with these constants here, and the SwitchBoard function. And again, that controls navigation in the game, program flow. Boolean items here. I have to be able to code away, I have to be able to tell in the game if the player's gone to a certain location on the map and they found inventory items. If they go back, they can't find that inventory item all over again. You understand? or if they've done battle with a dragon or a giant or, you know, a beholder beast or something. That was so Dungeons and Dragons. But, you know, when they go back to that location, they need to see a corpse. We don't want them to have to do battle all over again with an opponent they've already defeated. So we have to keep track of the game state, okay? We have to keep track of what the player has accomplished and what they have not accomplished, what they have found and what they've not found. And that data, the environment data, is a separate set of data from the data that would go with the player object. So, in other words, the player, as part of their character object and the character class, they have attributes which we'll look at in a moment. They may have 2 or 3 healing potions, okay? But that data is completely separate from the environment data, where if the player goes to West 2 or location North 3 and they fumble around a brick wall, they find another healing potion, okay? Well, that's a completely different set of data we have to keep track of. And actually in this game, we do 2 saves when we save the game. One file saves the character state and the character's inventory and level and attributes and all the magic items that the player has acquired. And the second file holds the game state, which is the booleans and integers that define the environment and that must change throughout the game. And that if you save it to save the progress and then load the game, you have to load all those values and set all those values back again in order to put the player back where they were when they chose to save the game, okay? And that'll become more clear as we go over the functions, but this is a pretty long, large project, so it may take a while. So just going over our globals, and then here we have, we're using new object and we're instantiating or building some character objects. One for the player, and we're going to build a dragon and a giant and a shaman, okay? And starting out a larger project like this, again, I would always code my classes and create my inheritance hierarchy first. Put some thought into it, plan it out, chart it if you need to. Use MS Project or something, or Visio or whatever you want, but I kind of think in code, and I just kind of sketch things in code, but it's, I just kind of draft it in code, or sort of my own little weird, semi PowerShell, but not necessarily shell, but you've heard the expression, right? Measure twice and cut once. So the more thought you put into planning your project, the more carefully you measure, then the less cutting you're going to have to do. If you don't plan it out and put a lot of thought into the design, it's going to take you 3 times as long, because you're going to have to go back several times and undo everything that you've done, because only then will you realize that you weren't thinking of certain logic problems that your current code can't handle, or there were unforeseen circumstances or things that arose that you didn't even realize you'd need until you got to a certain point and you're like, oh my gosh, I need an intermediate class between this ADT, abstract data type, and my derived object or something. So however you like to do that, a lot of people will just sketch something with, pencil and paper. Who cares? There's no right or wrong way. Ultimately, in the end, if your application works and does what you want it to, you win. Okay? That's all you care about. We don't really care how proper your design process was, or what software tool you used, or if you just used a pencil and paper to sketch out your ideas first, or flowchart, or whatever. It doesn't matter. But I'm just saying, whatever works for you, put some thought into it, into planning your project out first, because whatever time you spend doing that, it will immensely save you time later when you start coding it. Sometimes before I start a project, I will spend days thinking about it. I'll sit down in a chair and just stare at the ceiling for hours and just go over it in my head and just plan and think, well, okay, how am I going to do this? And then if I do this and this happens, then what am I going to do? And then there's a contingency, and then what will I do? And then if that happens, then what will I do? Seriously, sometimes people, they think I'm not doing anything, but sometimes when I'm sitting in a chair staring at the ceiling, I'm thinking, how the heck am I going to code this out? Or how the heck am I going to control the flow of logic? in a fairly straightforward manner. So whatever works for you, use Visio, use MS Project, use a pencil and paper, sketch it out in pseudocode. Pseudocode is just basically just like, you're using a bunch of comment tags and putting notes, and you're going to go back in and fill in the code later. But you're just sort of sketching out your raw ideas with comment tags. Now, the very first class that we would code would be a base class. And we may have several base classes. And usually that class is an ADT, or abstract data type. And that simply means that you're never really going to instantiate or build an object from your ADT, from your base class. It's simply there as a foundation of code for all of the derived class objects that you'll create from it later. So it's there as sort of the ultimate great-great-grandparent for all of the great-grandchildren that you will derive from that class. They will inherit from the abstract data type, from the base class, okay? So you would start out and you would code your base classes. And I'm thinking, well, I want to have giants and dragons and beholder beasts and elves and mages and warriors and fighters, all those different kinds of classes. So what are the things that they might have in common? Well, they're entities, right? I mean, at some point, even if whether they're an NPC, a non-player character, or whether it's the player object themselves, or even two humans going at it in some sort of online situation, something they all have in common, along with dragons, ogres, giants, whatever, they're all entities. And by that I mean they're life forms, right? They're living things. So they will all have attributes in common. And if I define those attributes in my base class, all the things that they might have in common, that will save me hundreds and later even thousands of lines of code in my project later on. Because then I can just build, write a new class that inherits from an ADT or a base class, and that'll get all those data members and all those methods and all that functionality built right into my new class. And then I can instantiate it and do something with it. And, when you put some work into laying a foundation, and you lay a good foundation, then your programs will be, far easier to add functionality to, and to modify and to adapt, okay? So in this base class, my data members, things that all those objects would have in common as an entity: HP or health, attack, defense, experience, score, weapon choice, weapon damage, magic choice, magic damage, magic cost, armor choice, entity class, name, gender, invisibility count for those entities that can use invisibility. All these are things that I would put in my ADT, my base class, that my derived child classes could then use that code. And this way I only have to define it one time. Okay, what am I doing here? Overloading or overriding? I'm overriding the default constructor, creating an entity object at the console, because I want some feedback. I want to see what's going on there, what I'm doing. And I'm just initializing these values to defaults with the this pointer, okay? And then we have some accessor methods, okay? And this is just set armor and get armor. I have one accessor method, and that's just going to take care of what I pass in as an argument, armor. Okay, I'm going to switch on it, and then if no armor, they have no armor. If chainmail, then chainmail, and it's going to add 5 to their defense. And plate mail, it's going to add 10 to their defense. I could allow accessing armor directly, as a data member, but I don't want to do that because armor has no meaning outside of the context of defense score, okay? So in this example, that's why I did that. I wrote an accessor method, set armor, and it's just going to add 5 or 10 to the defense depending on whether they have the chainmail or the plate mail, which one they're wearing. Okay, and then I have an accessor to get armor. In PowerShell, remember, there's always a set and there's always a get in most PowerShell commandlets. So here I'm just returning the value of armor choice using the this pointer, okay? So DisplayStats, This is just going to take care of displaying an entity object. And there's quite a bit to do here. And we haven't even added vector graphics or a real game engine or a graphical interface yet, but there's still a lot to do to display an entity object. If we're going to show an entity, we have to display all of its data members, right? We have to show its attributes and somehow get that information to the console. So that's what DisplayStats does. It's a member method, and any class that inherits from entity will have access to it. And if they call it, they can get access to and display or output the values of all their parent or grandparents' attributes from the abstract data type. So name, gender, HP or health, attack, defense, experience, score, class. And then we have to switch on these, right? The weapon trace, because that goes on as a numerical integer constant. But then based on that, we will change the string of what we detect. So weapon trace, ultimately that's really an integer, okay, that gets changed. But we'll give that integer a meaning by converting it to a string in this switch statement. So based on the value of that integer of weapon trace, we will display broadsword, dagger, staff, crossbow, longbow, or whatever. And if the player has nothing, we'll take into account their gender, whether they're male or female, and say nothing but his or her fists, okay? Armor choice, no armor or chainmail or plate mail, same thing. It's an integer numerical value, but we're switching on it. So based on that integer numerical value, we will change the value of our string output, okay? And magic choice, same thing. We're doing the same thing here, integer numerical value, but we're changing the value of the string. So fire, ice, lightning, telekinetic force, invisibility, healing, depending on the numerical integer value. And of course, there's an amount of magic energy or mana. Maybe I should have called it mana, but I figured I'd try to do something at least a little bit different. So called it magic energy, okay? So all of that is a string, and it's using the overloaded addition assignment operator. It just keeps concatenating and adding it to the string, and finally when we get to the end, it writes it to the console, that whole string, okay? So that is the DisplayStats member method in our base class, our entity class. And now we have an attack method, okay? And do you remember Godzilla, in the videos where we went over Godzilla versus Mothra and all those videos? Well, it just does something similar. And I'll go over this in the final version, maybe in more detail, but I'm just going to skip through it pretty quick right now to hopefully cut down the amount of time this video takes to record. Okay, so this will simply take an opponent. So any entity can attack another entity. Any entity can engage in combat with another entity. So when one entity attacks another entity, that entity gets passed in as a parameter or an argument as opponent, okay? And we're just going to say attack for this.name, which would be this entity object's name. And then we'll pause, and then we'll display their opponent's stats, right? We want to see who we're attacking. What are their attributes? What are the values there? And then opponent.name, their health or their hit points before the attack. We generate some random damage here. Now, if the entity class is warrior, fighter, or elf, okay, these are the only classes that can use like weapons or heavy weapons. Other classes, we don't, they can't use the kinds of weapons that these classes can. So it's up to you, but this is how you could do that. You could create an if decision block, and you could say if that class is warrior, fighter, or elf, well then we will allow these weapon choices, right? Dagger, bowstaff, longbow, crossbow, broadsword. But if not, we will not allow them those weapon choices, okay? And based on that, each of these weapons has a different damage point value. It's a numerical integer value. So some weapons do a lot more damage than others. And so that amount is added to the random amount of damage that we generate up here. And then we get down here, and then in addition, whatever the entity's attack strength is, right, their combat experience, that gets added. So right here, we're adding that. And that's being added to our random damage here, and we're displaying it here. And then our opponent, they get to defend. So whatever their defense value is, they get to subtract from the final amount of damage, right? So even after they increase the weapon. All right, depending on the class, we may or may not allow them to use magic. And in this case, Mage, Shaman, and Elf are the classes that can make use of magic, okay? Elf is sort of a hybrid class, can use weapons, not the heaviest weapons that only fighters can use, but a lot of weapons, and they can also do some magic, and they're pretty skilled, but maybe not as good as a Mage, but they can do most magic, okay? So they're sort of a hybrid class, but anyway. So if another if block, same thing we did with the weapons. And if it matches any of these classes, then we're gonna let them use magic. And magic can add damage points along with the random damage and along with the weapon damage, okay? So this is sort of a combined joint attack of using magic and a weapon at the same time, if the entity is capable of it, whether it's an NPC, an opponent, or whether it's actually the player herself, okay? So we go through that, and then invisibility does something completely different. Invisibility simply will increase the defense and make it very difficult for that player to sustain damage from their opponent. So it will dramatically increase their defensive capability and increase the likelihood that when they engage in combat with their opponent, that they will miss when they're attacking the entity object itself, okay? And in this case, if they activate invisibility, self, and increasing their defense, we're just going to increase their defense there. And they also have the option of healing, which can restore their health. It can add a certain amount to health. And finally down here, we're going to subtract any defensive amount that our opponent has. And then when we get done, we're going to display the stats. We display the opponent's stats, but after each attack, we're going to display the entity's stats as well, okay? All right, so that's our ADT. And it's quite a bit of work coding that class. But once we get it done, we can make really good use of it, yeah? So we're just going to test it. This is definitely not our final product. And normally you would never instantiate an object from your base class or ADT. But when you're testing, in the testing phase, yes, then you would instantiate objects from your ADT. So we're going to make player as a variable. It's going to use new object and create a new entity object. It's our base class, our ADT. We're going to set some values. Curly, female, elf, attack 75, weapon choice, global, crossbow, and the magic choice will be lightning, and she will be wearing plate mail, and then we're going to call DisplayStats, and we're going to build an opponent as well, okay? So we build another entity, and his name will be enemy, male, and warrior, and we're going to use the attack method in our ADT to test it. So player is going to attack enemy, okay? And we'll just test one sequence of that and see how that works.
Okay, so we're just pausing, right? And let's just read host, and we capture the input and we just assign it to null because we don't need to do anything with it. Read host returns a string, but we don't really need a string. We just wanted to kind of pause the program flow in the game, right? Until the player hits enter. So player hits enter, and building a player object. Okay, so again, we're hitting pause. So we build the player and we display the player stats. Curly, female, health 100, attack 75, defense 15, experience 1, class elf, selected weapon crossbow, selected armor plate mail, selected magic lightning, magic energy 500. Okay. So when we do that, now we've got to build the opponent, right? We have to build the enemy. All right, so now we build our enemy. And notice the constructor. Notice the inheritance, right? When in this case, we're building an enemy, but when we do that, it calls the constructor for our base class, our abstract data type, okay? Everything looks good there. Hit enter. Now we're going to try the attack method. And here we go. Attack for Carly. It retrieves my opponent's information and then displays it. Before Carly's attack, enemy's hit points is 100. Carly fires a bolt from the crossbow twang. A random amount of 18 damage was generated by Carly's experience and luck. Attack combat skills add another 75, making it 93. Weapon increases it by 18 for a total of 111 damage. Carly blasts her opponent with a lightning bolt, and that subtracts 30. In this case, after the, there's 141 damage, and then my opponent, the enemy, they have a 5 for defense, so they get to subtract that from the final damage. And then in this case, my enemy has been defeated in battle. Okay, and here's Carly's stats at the end of the attack sequence. Okay, and we could also add the opponent if we wanted to. Display stats. We'll do that as well. We'll display both stats. All right, so we'll run it again. Okay, build our player object from the ADT and build our opponent object from the ADT. Right, there's our constructor. And now we're going to call the attack method down here. So player is going to attack enemy, right? Here we go. Carly fires a bolt from the crossbow twang. A random amount of 20 damage was generated by Carly's experience and luck. Carly's attack combat skills add another 75 to this, making it 95. Carly's weapon increases her attack by 18 for a total of 113 damage. Carly blasts her opponent with a lightning bolt. This ionizes their molecules and strips away minus 30 health. This forceful burst of magic costs 30 units of magic energy, but it increases her attack by 30 for a total of 143 damage. The enemy's defensive skills, their defense score is 5, so subtract 5 from the final damage. And then we deal our final blows. And Carly's health is still 100, and our opponent's health is now 0, okay?
So that would be the first iteration in this development cycle. That'd be the very first thing that we would do. We'd want to create our globals, our variables, and we want to write our base class or abstract data type, and there could be more than one. In this example, we only have one so far. But we packed a lot of code into it. We packed a lot of functionality into it, and good grief, this is really a brief base class or ADT. We could add hundreds more lines of code into this object. This is just sort of a brief example. But all of that is in our base class, right? All this code. So all of that code, when we build an entity object, we get to use all of that code. And later in our inheritance hierarchy, as we write new classes like elf and warrior that inherit from entity, or an intermediate class like character that inherits from entity, and then the elf inherits from character, it gets to use all that code over and over and over without having to reinvent the wheel. Okay? So inheritance hierarchies are a beautiful thing, and inheritance is a beautiful thing in terms of simplifying your projects and enabling you to do a lot more while writing a lot less code. So I have all these globals here, and in the previous video we talked about how they're used to save game state data. These are used as integer or numerical constants for navigation in a function later that we'll use called SwitchBoard. And these are used in the environment, to keep track of what the player has found and things the player has done. And that way, if they go back in the environment, then we can save those changes, keep track of those changes. We have a couple of global objects here to allow things to persist in our global namespace, right? Basically pointers that will point to a player object and a wise woman. Okay, so those are objects we'll instantiate from our base class later. To start out, we have an abstract data type, a base class. It's entity. Here's all of our data members. Okay, and we have overridden the constructor, and we're just initializing these values in our overridden constructor. We have an accessor method, a set and a get for armor, and we talked about all that in the previous video. We have a DisplayStats, and talked about that. We have an attack function, and we talked about that, right? in the last video. Okay. So that was our base class, our abstract data type. And you don't normally ever instantiate an object from your ADT or your base class. It exists basically as a structure to lay down the foundation and code for the objects that will inherit from it. And then when you build something, an object, and you allocate resources, you build a more specific derived class of that ADT or that base class, right? You build a child object from it as a parent or a grandparent object. Okay, so that was our very first class, our ADT. And I will find somewhere to put that code. If not on GitHub, I'll see if I can't put it in comment tags in the video or something. And okay, so now we're going to create an intermediate class called monster. All right, and the way we do inheritance and with PowerShell classes is just with a colon. So keyword class again, monster, and then it inherits from entity. Sorry, that's our base class, our ADT. But monster itself is also a parent object that will give birth to its own children. It's also really an abstract data type, if you think about it. You don't just have an entity, you have a more specific kind of entity. So entity is just sort of a hub or a foundation of code around which you evolve other things from. Well, in the same way monster, you don't really just have a generic monster, you have a more specific kind of monster, a dragon, a beholder beast, you understand what I'm saying, a giant, a unicorn, whatever. Well, I don't know if I call that a monster, but so this itself is sort of an intermediate base class or ADT. But we could have functions, methods, attributes specific to anything that would derive from the monster class. And then it would get not only the monster class, but also the entity class, attributes and member methods and inheritance. And now we have a dragon, and it inherits from monster. And remember, monster inherits from entity. So a dragon can do anything that monster can do and anything that entity can do. And a dragon has all the attributes of a monster class object. And in addition, because monster inherits from entity, a dragon also has all of the attributes of an entity object. Okay, so, name and the potential to use magic and weapons and all kinds of things. Sky's the limit. Depends on what, what we want to do with that basic foundation of code that's in our ADT or our base class. Additionally, a dragon has specific things that only it can do. So breathe fire, breathe ice, breath acid, treasure, an amount of treasure. So, breath weapons, things like that. Things that would be specific to a dragon object and, more specific things. A breath attack, deploying breath weapon, okay? Now this is a giant. It also inherits from monster. And remember, a monster inherits from entity. So it's part of our hierarchy. And a giant has a club, and a giant also has an amount of treasure. And that's a method of attack, a function that's specific to a giant class object, okay? So in the same way that monster is an intermediate ADT or base class, it inherits from entity, but it's also the parent of child objects. So is character. Character inherits from entity. So all the things that are an entity, name, attack, defense, health, a character also has those things because, it inherits from entity. But character itself is an ADT. So character has other data members and attributes, whether or not, it has items in the game, inventory items that can be found and used in the game. Healing potion, the fish key to, solve a map puzzle, chainmail for armor or a crossbow or a broadsword for a weapon, okay? Examples of that. Okay, here we are overriding the constructor again, right? Class name's character. Function with the same name. That's where we're overriding the constructor to do our own thing. And in this case, we want to initialize every character object that gets created, that's instantiated, with this set of default values, okay? And we have a cheat function here. And a lot of times when you're doing a game, it's useful to write a cheat method where you set all the inventory items and all the abilities and everything that you can find in a dungeon or a map or in the game to true, because it gives you a quick way to test everything out, okay? And so if we want to do that, we can just call this cheat method. And that also is built into the character class, which inherits from entity. We have a DisplayInventory method, and it just goes through and uses those booleans to display the inventory that we have based on, whether it's true or false that we have found and acquired those items in the game. Now arrows is a bit different because that's a quantity item, it's an integer. These are just boolean. A character object either has them or they don't, true or false. This, on the other hand, is an integer. It's a quantity amount, okay? The character can have a certain number of arrows. Every time the character fires one through the longbow or the crossbow, then their arrows are depleted and they lose an arrow unless they find more arrows. So we have to keep track of that, and that's different. Same thing for healing potion, right? These two are not boolean, not true or false. These are quantities. So they're integers, they're numerical. And then finally, this is just a sort of a compound logic condition right here in this if block bit. We're saying if all these are false, has broadsword, has dagger, has staff, has crossbow, if basically the character doesn't have anything, and then we're just going to display they have absolutely nothing. Okay, now these are ways to display our inventory, but we need a separate function if we're actually going to use inventory. We have to give the player a choice, okay? And this is all in our character class. So in this case, we're going to go through and we're going to show currently selected weapon. And if there is no selected weapon, we'll say nothing but her or his fists based on gender. Otherwise, we'll show broadsword, dagger, staff, crossbow, longbow, whatever weapon they might have selected, okay? And we're just showing that, and we're showing the armor that they have if they're currently wearing armor. And then we're going to call DisplayInventory to show them their inventory. And we're going to ask them, hey, player, which item do you wish to use? And we're taking that input via read host, so it comes as a string. We're converting it to lowercase, and we're passing it to choice here, right? It gets stored in choice. And we're only switching on the first character of choice. It makes our game a little more forgiving in case they type a typo or mistype something. Why? Because we only care about the first character, right? And in this simple console menu. So this makes it a bit more forgiving. They could misspell or mistype anything after the B, and this way we won't care. Whereas if we took that as an entire string and compared it, then our game would be less forgiving of things like typos. So it kind of makes sense to reduce what you're switching on to a single character, if that's all you need. You know what I'm saying? Don't use more than what you need. Makes it easier on the player, more forgiving to the player. Okay, so based on what they choose in our switch statement, we're going to set that as their selected item. All right, so their weapon choice would be set to broadsword if they chose B, broadsword, or it would be set to dagger if they chose D, dagger, or it would be set to staff if they chose S, or crossbow if they chose C, right? Okay, but we need a little bit more logic here because we can't allow them to select a weapon if they don't have it, okay? And we could choose not to give them any feedback, but in this case, at least in this early version, we're going to give them, hey, you can't do that, you don't have the broadsword. Or, hey, you can't do that, you don't have the dagger. Just some feedback, okay? Now, for weapons that use a quantity item, for instance, they can select the crossbow, right? If they have the crossbow, then we can allow them to select the crossbow, and they can prime it with an arrow, but only if they have more than 0, right? If they don't have any arrows, what good's a crossbow? So they can't use the crossbow in their arrows, But if they have greater than 0, if they have at least one arrow, then they can select the crossbow, prime it with an arrow, and the weapon choice would then become a crossbow. It's the same for the longbow, right? I mean, the damage amount that a longbow does in the game, it's less damage, but it still requires an arrow to be able to fire it and to use it. And then in addition, they can choose, if they're not wearing their armor, so they can move around faster or for whatever reason. Different armor has different qualities. Some protects you from fire, some protects you from ice, and some protects you from, ballistics, whatever. So if we give them the opportunity to change if they have different types of armor and their inventory. So if they have the chainmail or if they have the plate mail, the plate armor, okay? And when they do that, we have to check for several things, okay? So if they have no armor, then they can put it on. And if they have the plate mail, okay, well, they can put it on, but they have to take the plate mail off to put the chainmail on. So we have to code for that contingency. So we have an if they have no armor, then they put it on. Else if they're wearing the plate mail, else if here, well, they take off the plate mail, and we have to subtract 10 from their defense, because that's what the plate mail does, it adds 10 to their defense. And then they put on the chainmail armor, okay? And, and then if they do, when we call set armor, this successor method, this will add 5 to their defense. And that's the amount of ballistic defense that is increased when they wear the chainmail, okay? Else, if it's the chainmail, in this case, if they choose chainmail and they're already wearing the chainmail, we're assuming they want to take the chainmail off. And so this acts as a light switch. It toggles on and off if they're already wearing chain armor so that they can take it off, okay? And we would subtract 5 from the defense. Doing the same thing with plate armor, if they choose a healing potion from their inventory, we have to make sure that it's greater than 0. It's a quantity item. And if it is, okay, then they can use it, and it's going to increase their health, their HP, by whatever health potion restore amount has been set to. And then we have to decrease it from the potions in their inventory. So if they had 3 healing potions, we have to decrement, we have to subtract, and now they only have 2 healing potions, okay? Otherwise, if they have none, if it's not greater than 0, we tell them, hey, you have no healing potions. You can't do that, okay? We're going to display the results of their weapon selection after they choose a weapon. And then here, we're just going to show their currently selected armor, okay? So all of that goes in the DisplayInventory and the UseInventory functions. And DisplayMagic is something similar. This works just like DisplayInventory did. So if they have that ability, if has fire is true or has ice or lightning, then they can choose that ability and we'll display it. They'll see fire, ice, lightning, telekinetic force, invisibility, healing, okay? And if they haven't found any scrolls and defeated any opponents and they don't have those magical abilities, we'll just simply tell them, you have no magical abilities yet, okay? We'll display their current magic energy, and that's kind of like mana. You need a certain amount of magic energy to be able to pull off different spells, different types of magic. So it's just like mana, okay? And then based on a choice, based on what they decide as far as their magic choice, then we're just going to append that, accumulate that within our string, and we're going to display our string here, okay? So that's just to display their magic abilities. Just like we had 2 functions, one to display inventory and one to use inventory, we have 2 functions for magic. The previous one we just went over displays magic. This is to use magic, okay? And in this case, we're going to take, which magic ability do you want to use? We're going to take it in via read host. It comes as a string. We switch on it just like we did in the use inventory method. And similar logic, we have to check and make sure that they have that capability. They have that scroll, they have that magic ability before we let them use it. And otherwise, we assume if they choose you, they're unequipping themselves. And that's if they want to recharge their magic energy, okay, or their mana. So here, has fire, has ice, has lightning. We have to detect first, do they have it in a logic block? And then if they do, okay, so if magic energy is greater than, every magic ability has a magic cost. We have to make sure that the amount of magic energy they have, like mana, that it's enough to cover using that particular kind of magic for that particular instance in combat or in the game, okay? So that's all we're doing here all the way down. Now, with invisibility, we're doing something a little bit different. This makes them a lot more difficult for their opponent to hit them. And it gives them a huge increase in their defensive capability. You can't really fight an enemy if you can't see them, right? It gives you an incredible advantage in combat if you can turn yourself invisible. It's expensive in terms of magic energy, but it can last for several rounds of combat and give the wielder of invisibility a huge advantage in combat. Healing, just if they have the magic energy, they can restore some of their lost health, right? They sort of lay hands on themselves and heal themselves, okay? So, and here we're just displaying the selected magic ability after we've gone through and checked and made sure they had enough magic energy to use it, and also made sure that they had found the scroll and that boolean was true and that they could use it. Then we'll display what's selected, and it will be selected, and it can be used later in combat, okay? Now this is an empty method, use potions. Right now, I'm doing it all with the inventory function. That handles all my potions. So I don't really need this, but it's just sort of there as an idea. I stubbed it out. A lot of times you'll do that in code. You have an idea to expand something later. So you'll create a function or a method and you'll just stub it out with a single line of code. Write something to the console. Code for this function goes here later. So later I want to make a more extensive function that allows more capabilities with potion usage than simply inventory does. So for now I'm doing all that in inventory, but my plans are eventually to split that off into a whole separate function written just for handling potions, okay? So, from character, which inherits from entity, we're going to create Shaman. So Shaman has as its parent character and as its grandparent entity. So a Shaman can do everything a character can do. It has all its attributes and all the members of a character. And in addition, it has all the attributes and all the methods of an entity. So that's hundreds of lines of code that go into a Shaman just because we coded it to inherit from character, which itself inherits from entity. So I hope this is beginning to show you the the usefulness of an inheritance hierarchy and how it works. Here's our overridden constructor. We initialize some values, and a Shaman has a special function, right? In this case, a Shaman is an NPC, a non-player character. So it has a special method associated with it to just sort of simulate conversation, almost like a chat bot. And it'll generate a random number between 1 and 10, and you can have conversations with the Shaman. The player can, and ask the Shaman questions, and the Shaman will occasionally drop random clues here and there. I like wildflowers. They're very beautiful, and their restorative powers are merely a fringe benefit. So that might be a clue that if you find a certain kind of flower and you were to make a potion from it, it might be a healing potion. Or it could be poison. Who knows? But do not look on the outward appearance of things. Characters should be judged by what is on the inside. All right, so we're just dropping clues there. To unlock the gate between worlds, one needs a key. So it's sort of a clue to the player. If he conversates with our NPC, with our Shaman, then the player, she will learn that she needs to find that key in order to unlock the gate between worlds and to be able to get back home. Okay? So that was Shaman, that inherits from character, that inherits from entity. This is Warrior, that inherits from character, which inherits from entity, and Mage, and Fighter, and Elf. And these are all classes of character that our player can create. They'll be given the choice and the option to build those different classes of object when they play the game. So now that we've completed and coded our inheritance hierarchy, all of our classes, right? And that was about 1,330 lines of code or so. Now we're ready to actually start building and instantiating objects from our class hierarchy, our inheritance hierarchy, and begin using them in functions to do things, to actually, play the game. So we have a helper method here that its only purpose is to pause using read host. And again, it stores the return value in null because we just don't want to let it, fly off and even though we're not using it, we still always want to catch that return value. We have a main function, and that basically gives us our main menu. Okay? And our main menu gives us several options. We can choose a new game, load a game, save a game, or quit. And it's just in a switch statement here. Now here's where all the game navigation takes place, okay? So what we do is we manipulate and control these values, and we change these values inside of different functions. And as we do, we constantly go back to this function called SwitchBoard. We will call or we will invoke SwitchBoard. So based on these values, it just gets passed into a switch statement. And this loops until either the player dies or they quit, okay? And then based on these values, so we just call different methods, different functions, and that moves them to a different location. So if location becomes C1, we call center 1, N1, north 1, okay? So next function, SetupCharacter, we have to allow them to choose or build a character. And that's all we're doing here. Decide which type of character you wish to create. So here where they choose to build a character object, we're just going to keep them in this while true loop, right? We'll keep them in a holding pattern until they choose a valid character. And then when they've chosen the character they want to create, do they want to be a warrior, a mage, a fighter, an elf, a shaman? Help if they need help deciding which character they want to be. Based on their choice, we're going to use new object and we're going to instantiate or build that character of object, okay? So those are all of our options there. And then we'll allow them to choose a name and choose a gender. And we'll also generate some random stats and ascribe them to their character. In this case, their HP 200. And then we're going to call InitializeGlobals. And this is our game environment data. What we have to initialize for a new game. And so depending on that, found healing potion would be false. They haven't found it yet. It's a new game. S1 dragon alive. The south one, the east one alive. Center first time true. These would all be true. These are all just game values, game environment values that we need to initialize in the process. Introduction function, just, basically it sets the scene and then sets the start location to be C1. And remember, that goes back to our switchboard. So if it's C1, it calls the center 1 function. And as we change these values, remember, we keep calling switchboard and it keeps sending them to different functions. So that's how they walk through the map, okay? Now they can choose O for options at any point in the game. And from options, they can look at their inventory and use an inventory item. Look at their magic abilities, potions, display their stats. They can load a character in a saved game state, or they can save their character in the game state. All of that is available via an options function. And to do that, we just coded it and put it inside of a function called options, right? And then same basic pattern for a menu in the console. It's always in a while true loop, right? You give them the choices, you take the input, and then you switch on it. Okay, so that's all our options menu does. So let's go on. RoleHelp, it just gives them some information about the different classes of character that they could create when they call the create character method. Now, here's where we do a bit of file access, okay? And we'll come back and take a look at that, but and the files that it creates. But basically, we're going to create two files, two CSV files. One will save the character state information. The other one will save the game state information, the booleans that go with that, okay? So character.csv, gamestate.csv. And this is just a way of getting the parent directory, the directory that the script is being run from. That's where we will save the game state and the character state files, okay? And we'll give some output to say what we're doing. And we're going to serialize what's called serializing a class. So our instantiated character object, our player object, we have to save every single data member in the character class. Well, let's say we have an elf, okay? So we have to save every single attribute value that's in the elf class, and then every attribute value that's in the character class, and then every attribute value that is in the entity class. Because remember, elf inherits from character, which inherits from entity, okay? So that's all we're doing here. And if you go back to the file access video, you know, this is fairly straightforward, right? For writing a class of object to a CSV and all of its data members, all of its attributes, okay? And that's what we're doing right here. We're finally writing the character state to a file. And here we're doing the same thing with the game state data and saving that to a file. We'll come back to that, right? But and here we're just inverting that. We're loading the character state and the game state. And you know, after we load a character, so we import CSV, and then in this case character input. Well, character input is our file, our directory data, right? And then character type is equal to character state dot entity class. Okay. Well, that's what we read in from the file, and that's just the name of a column, all right, or a data member in the class, and we assign that to character type, and we're going to switch on that. This is just a broad overview. We'll come back and look at file access. So if this seems confusing, don't worry. I'm just trying to give you a brief overview of the code. I'll be lucky to get through this in less than an hour. Oh, 3,300 lines of code. Okay. And my throat, I don't know if my throat will hold out. Okay, so we're assigning values here. So character state, that's the file that we read in, our CSV file. And then these are the column names here. And we're just assigning that to the player, right? And we just built a new player based on the, you know, in this case, the entity class value. So that's how we know, was it a shaman, a fighter, a mage, a warrior, an elf? Well, we have to build the appropriate object. And then once we do, with our file, with the data in our file, we just read that in and we populate the attributes or data members of our class object with the data from the file. We do the same thing for game state as well, okay? Down here, we're doing the same thing with game state. So that's all that's going on in load and save, okay? Booleanate it. In this case, a Boolean true false in PowerShell is not the same thing as what we get from import CSV with a file. We're just getting string data from the file. So this is just a quick helper function that I wrote kind of like the is it a number function or the pause function, just a quick short function, and its only job is to convert the data type from a string data type to a boolean data type. So if it reads in a string as true, comes in as an argument, a parameter, then it returns boolean true. And if the string data is false, then it returns boolean data type false. Okay, so that's, and then if we pass something weird to it that we shouldn't, it'll warn us that data is not booleanable. If that's even a word, who knows? But okay, we have a function called pre-combat, which we will call selectively. Player doesn't always get the chance to prepare, but if we do choose to give the player the chance to prepare, we'll call pre-combat. And that calls UseItem and UseMagic. So we let them select inventory items and magic items, okay? And then we get down to combat. And combat works with attack, okay? This combat method. And we have to go through and, in this case, the player and the opponent are locked into combat. We're going to pause for 2 seconds, and then here's a coin toss, right? Random number between 1 and 2, coin toss. Who gets the first attack? It's the luck of the draw. It might be the player, it might be the opponent. Who knows? If the player gets the first attack, then what happens? While the player's HP or health and the opponent's HP or health are both greater than 0. Remember, Anne says both sides have to be true. If and only if both are true, then this while true loop here, this block, will continuously iterate and loop in our combat sequence. And what happens? Well, if the player gets the first attack, then X, as long as X is not dead, as long as his HP is greater than 0, X attacks Y. So player attacks opponent, and then sleep for 2 seconds. Otherwise, what happens? If that's not the case, and then, okay, so X attacks Y, then what happens? Y attacks X, right? The opponent gets to counterattack. After the player attacks opponent, the opponent gets to counterattack. So this is basically just inverted, okay? And all of that will continuously loop in our battle. That's our combat sequence until we have a winner. And any methods or functions we call from attack, such as letting them choose or switch weapons or inventory items or magic, okay? Okay, and if not, if first attack is equal to 2 in this case instead of 1, well then what if the opponent goes first? Well, here we just invert. Here X attacked Y and then Y counterattacked X. Well, here Y attacks X and then X counterattacks Y. So it's just inverted logic. But it's based on that random coin toss we have up here, right? Who attacks first, right here. Okay. So also, the very first time through, we're going to show the opponent's info, right? Their stats. But we don't want to do that every single time. That would get tedious. So these are true, but then we can toggle them on and off. We can set the values to false to choose not to display their stats. Finally, when we get to the end of our combat sequence, we have a winner, right? Somebody won, somebody lost. Somebody's still alive and surviving, and someone has been dispatched in our combat sequence. So that's all that happens here. If the player is greater than 0, then that means the opponent lost. So it's the sole survivor of this battle and was terminated with extreme prejudice. That's their opponent. Otherwise, if it's not greater than 0, well, the player died. They lost. In which case, their opponent was victorious, and the player was dispatched without mercy. Does that make sense so far? Okay. So let's look at how the map functions. All the rest of these functions here, they're related to locations on the map that the player can walk through, okay, that I'm scrolling through. So, for instance, center 1, start out, we I'm talking, I can't handle these hour-long, boy. I get tongue twisted. Okay, display stats, the player display stats, okay, and we're just showing the location. They're in center 1, all right? And then if they're in center 1 for the first time, we display this. But if they come back to center 1 and it's not their first time, we display this, okay? while true loop and our valid options are always going to be the valid locations they can walk to on the map, okay? So while it's not equal to north, south, east, west, those are all valid options. Or look, so these are all exit conditions. North, south, east, west, or look would all be considered an exit condition. Anything else, not an exit condition. And we will keep the player in this holding pattern inside this loop until they select a valid option, or if they select quit, okay? Otherwise, where will you go? North, south, east, west. And they can also call the options function. That's an every location function. So every room in our dungeon, every location is a separate function. See how that works? So, and then based on what they choose, their choices, right, that we take via read host, well, we process it and we switch on it. And if they choose north, then we change location, all right? If they choose south, we change location. So north one and south one and east one and west one based on their choices. Because this location here, center one, that function, that's right in the middle of the dungeon or the middle of the map, okay? If they choose options, which will then give them access to inventory and other things, well, that's here. And if they choose to look, well, we just set the location. They're currently in C1, and we set it to C1, and we break out of this loop here. And what happens? Let's go back up to SwitchBoard and remind you of what's happening and taking place in SwitchBoard. Okay? So SwitchBoard is calling all these functions, and it's looping. It's continuously looping. So when these functions end, program flow always jumps back here. It jumps back to SwitchBoard. So this is acting as our main game engine, or our main game loop, okay? SwitchBoard. So when they choose an option and we change one of these values, then program flow, it leaves the center function. We're done with center one. It jumps back to SwitchBoard because it called center one from SwitchBoard. And so when center one is done, it goes back to SwitchBoard. But we've changed the value, based on what the player selected. So they might have gone north, south, east, west, and then SwitchBoard would then call that function. Same thing, they go through that function, they look around, they make choices. When they're all done, it jumps back to SwitchBoard. And it just keeps doing that throughout the entire game. So that's how we navigate. That's how we allow the player to navigate around our map, okay? And we're just doing the same thing with north one. So that was center one. Same thing with north one, display their surroundings. They can choose south or north based on the map. But, if there are some directions they may choose to walk in which don't exist on the map, in which case it doesn't lead them anywhere. So if they choose north or south, right, they're in north one. Well, they can if they go south, they go back to the center location. They're going back to where they came from. But if they choose north, they go to north too. But there is no west, okay, and no east. So if they go east, they just they fail to scale the east wall. If they go west, they find some chainmail. Yay. But the only two directions that actually allow them to go to a new location on the map when program flow goes back to SwitchBoard at the end of this north one function, those only two options are north and south. And that's controlled by the map. So when you code this, you need to draw out a map of your dungeon, draw out a map of your game, and then code it respectively. And that will, then you can just keep referring to the map, and that will let you know what to plug into your cases and your switch statement. Because remember, each location is a function. each location on your map. And the cases that you put into your switch statement, those are going to be the options that are available from that particular room or that particular location on the map. Can they go north? Okay. Or if they cannot go north, then what? Something else. You understand what I'm saying? But you're only going to change the value of global location if they are allowed to, if they can, from that room and going in that direction, go into another room on the map. Because when the program flow goes back to SwitchBoard, which it continuously will because that's the game engine, it's running inside of a while true loop, then what they've decided, whatever we've changed these variables to, that's going to decide the next function that gets called. And that's the next room on the map, okay? So we're doing something similar with South 1 and East 1 and West 1. Okay, and when they find inventory items, we turn booleans on and off, and we can register the, if it's a quantity item, the number of potions or arrows they might have. They can engage in combat with dragons and with giants in the game. And going to South 2 here, just scrolling. So here is an array of giants, right? We build an array of giant objects. And once we do that, we're going to populate and fill our array. Gang of giants, right? Here's our empty array. We're going to use new object. We're going to build a giant. We're going to name them Zolt, Maruk, and Leotol. Okay? And after we build them and name them, we add them to gang of giants. We add them to our array. And then a quick and easy way to engage our player in combat with a whole group of giants is to create a for loop and use our array and call combat. And we just pass in a different element from our array to combat through each iteration or repetition of that loop. Okay? And then when we're all done and those giants are defeated or they have killed the player, we set them to be null, right? So we kind of clean up. Or we could choose to walk away and not face them, okay? So just trying to give you, trying to show you how you can code this in your game, how you can code encounters with giants, and how you can code finding inventory items, and how you can code having a conversation with an NPC. Okay, and then if here in East 2, they can find a fish key, which is necessary to complete the map. Okay, West 2, they can find a healing potion, and they can find a long bow. Here, if they found the fish key, then they can open the gates. Okay. And finally, if they come to this location, the Shaman's hut, they can engage in a conversation with our NPC, the Shaman character. All right, and it's just a valid option. They can choose to talk with the Shaman. And if they choose that option, we will call the talk method from her class. Okay. UndergroundPassage, we're doing the same thing. We create an array of 5 dragons and just lock the player into a combat loop to fight those 5 dragons. If he defeats them, we set them to null. Okay? And these were just some test functions when I was going through different parts of the game and testing things. But now remember, you can pause the video at any point and look at the code to see what I'm doing, to see how I did it. And I will make every effort to put the source code somewhere where you can, copy and paste it. But if that's all you do, you'll get nothing out of this project if you don't build it yourself. You understand what I'm saying? You should go through the design process. Carefully think out your inheritance hierarchy and code your classes. Draw out your map. That'll show you how to code your functions. The only way you're going to get anything out of this is if you do your own version of an RPG. but I'll give you my version of an RPG as an example. So let's go and play this game from the console, okay? And I'm going to create a new game, beginning a new campaign, and decide which type of character you wish to create. I want to choose, in this case, an elf. That'll be my character class. So notice the constructors get called. I'm building an elf object, but elf inherits from character. So it also builds a character object, which itself inherits from entity. So it also builds an entity object. Okay? So you can see our inheritance hierarchy at work in the gameplay. Give the character a name, choose a gender, and okay, you awake from what appears to be a disturbing dream, knowing neither where you've been nor how you got where you are now. Basically, we set the scene. Okay, this is the opening scene. Hit enter to continue. And this is the first location on the map where we find ourselves, center 1. And we display the player stats up here. And I won't read all the scenery because it would take longer, but my options are I can choose a direction, I can look around, or I can choose options. If I choose options, here's the options menu. If I look at my inventory, I don't have anything yet. Absolutely nothing. If I look at my magic abilities, I don't have any magic abilities yet either. Okay? So I can't really do much there. I have no choice. So I go back to options. I can display my stats if I want to. And I'm just going to exit. Okay? And look around. And again, I'm in that center 1 location. And because it's not my first time, I came back there. That boolean has been changed, okay? From true to false. And now this displays instead of the first item or the first text. And later on, we could change this to images or vector graphics or something. Okay? So I'm going to navigate around. I'm going to go east. And east again. And north. And south from the east 2 location. And I find the fish key. Okay? I'm going to look around, get my bearings, east 2. I'm going to go back west to east 1. Go back west to center 1. Keep going west to west 1. Keep going west to west 2. And then I reach the end of the map here. All right. So at the west 3 direction, I'm going to go north. And I find a longbow and some arrows. Okay. And then I'm going to go south and I find a healing potion. So I'm going to choose to equip these items. I'm going to go ahead and choose options. And I'm going to choose use an inventory item. And I'm going to choose longbow. Okay. And notice that my weapon was nothing but her fists. But now my selected weapon is longbow, which gives me a significant advantage in combat. I think that adds like 4 or maybe 8 damage. I can't remember what the point value I set on that, but it adds a significant amount more damage when I'm in combat. But only if I have arrows. Lucky I also got those 20 arrows in the map location, right? Okay, so I'm going to exit out of that menu. And I'm in west 2. So I'm going to go back east to west 1. And to center 1. And to east 1. And, oh, I see a dragon. Should we fight the dragon? Should we try to get it with our longbow? Maybe not be a good idea, but why not? Let's give it a shot, right? We see a dragon, so I'm going to go north. And I'm gonna, to the north, that's where that dragon is. So if I walk in that direction, all right, boom. We build a dragon object, which inherits from monster, so it calls the monster constructor, which in turn inherits from entity, so it calls the entity constructor. Entity constructor. So you can see our inheritance hierarchy at work here, right? Before inventory selection, longbow. I'm going to leave things the way they are. I don't need to change anything, but if I had multiple weapons, this is that pre-combat method or function, and so it lets me change my weapons and my magic trace before I lock myself into a combat round. So in this case, I don't need to change anything. Magical abilities, I have no magical abilities yet, so I can't really choose a magic ability there yet. So I quit. Okay, so I've made my selections. Enter to continue. Here we go with combat.
Opponent 1, Carly. Opponent 2, Deloria. And we're going to display Deloria's stats. Okay, her health. And here we go through our combat sequence. Attack. Carly fires an arrow from the longbows. So notice I have to subtract arrows from my number of arrows. A random amount of 45 damage. The combat skills add another 5 to make it 50. The weapon increases it by 16 for a total of 66 damage. I don't have any magic items yet, so I can't use magic there. At the end of it, well, I was attacking, so I'm still 200, and Deloria's 39. Okay. Now Deloria's attack, she's attacking me, and I'm the opponent. So she's going to deal 35 damage plus her combat experience, her attack score makes it 40. But my defensive skills reduce it by 5. Okay. So the final amount of health or hit points that she took out of me. I was 200, now I'm 165. So she took a pound of flesh out of me for sure, but I won the combat.
Carly's the sole survivor of this battle. Deloria was terminated with extreme prejudice, and I absorbed 50 points of magic energy, and beneath the giant beast's carcass I find a scroll. It teaches you a magic spell for creating lightning. Woohoo! So now I can use the lightning magic in my next round of combat, okay? And if I were to do that, look, if I were to pull up options and look at my inventory list, so I have a fish key, I have 18 arrows left, a healing potion, and a longbow. I'm going to go ahead and use my healing potion to try to restore my health. Okay, so I'm going to choose use an inventory item, and I'm going to choose healing potion. You drink the healing elixir and feel much better. Okay, and remember I was like 165, I think, in my health. So let's see what that potion did for my health. I'm going to call DisplayStats. Okay. So it added, 20 points to my health. Or 10 points. So I was 165 and now I'm 175. So it's 10 points. Now if I call inventory, well, I drank that healing potion. I used it up. So if I list my inventory, it's gone. There's no more healing potion there, right? Okay. But if I look at magic abilities, check it out. Now I've got lightning. Woohoo! All right. Anyway, I'm going to choose to quit. And exit this menu here and look around, get our bearings, and then that's our location. And okay, look, if I look north, I see a slain dragon, right? Because I defeated the dragon. And if I walk in that direction, I see a dead dragon carcass. So those are those booleans that we use to save the game state data. Because if the player walks back to that location, after the player did something, she fought a dragon or she defeated an opponent, you have to change the scenery, right? You have to keep track of the game state. So in this case, I am in East 1, and I'm going to go west to center 1. I'm going to go west again to west 1. I'm going to look north. And I find the dagger. Okay, so now I have the dagger item to my inventory. And I will look south. And in this case, I run into a giant. Yikes. I gotta fight a giant. Which item do I wish to use? I'm going to use the longbow again. Okay. And now for magic, I'm going to use lightning for my magic. All right, so if I do that, right, my selected weapon's now longbow, and my selected magic is now lightning. That was that pre-combat function.
And now I'm ready to go into combat. So, opponent 1, Carly, opponent 2, Gratham. And I get the luck of the draw on the coin toss. I get the first attack. I'm attacking Gratham. Carly fires an arrow from the longbow. So I've used 3 arrows, I have 17 left. That was pretty furry. I generated 1 damage. I think I missed my target. My attack, my combat experience adds 5, the weapon adds 16 for a total of 22 damage. But now I attack with a magic item, a lightning bolt. Minus 30 health. Okay? So, you know, I haven't been counterattacked yet, so my health's 175. My opponent's is 53. But now Grotham gets to counterattack. So now I'm the opponent and Grotham's attacking me. Okay? Generates, oh, good grief. Grotham's a lot luckier than I am. 42 random damage. And his combat skill adds another 5. So 47 total. So I'm reduced to 133 health or HP. But now I get to counterattack in this combat sequence. Grotham has 53 HP. I fire the longbow. 18 random damage plus 5 combat experience plus 16 for the weapon is 39. And then minus 30 with my lightning magic. Okay?
So finally, at the end of the battle, Grotham is dead. He's been defeated. His HP is 0. And currently is the sole survivor of this battle. Grotham was terminated with extreme prejudice. I absorb 50 points of magic energy and I find a spell for fireballs. Ooh, now I have fire and lightning in my magic inventory. See? Okay. So again, I'll look around and notice that boolean in the game environment. I have to flag that boolean as true or false based on whether or not the player has defeated their foe, right? So, into the south I see barbed wire, blood, sackcloth, and carnage. And that's the giant that I fought. And if I continue to go south, you see the corpse of the giant that you recently dispatched, okay? And let's look at our inventory real quick. So inventory list, I found a dagger, a crossbow, a fish key, and I have 16 arrows left after all my combat. And let's look at our magic abilities. We have acquired fire and lightning. And this is just a prototype. Obviously a real game would be a lot larger. And you'd have to go through a lot more rooms before you'd actually find other scrolls or other weapon items. But I packed them, you know, I packed them very close together to try to keep this code short. Hopefully under 4,000 lines of code, just to show you how you would code all these things, make all these things work. Display stats. I want to look at my stats again. Right, so my HP is down to 133. My selected magic is lightning. My selected weapon is longbow. Okay, and I'm going to go ahead and exit out of here. Actually, I'm going to do something. If I use the tilde, that's just that's a hidden cheat that I added into the options menu. And if I go to options, okay, the case of a tilde here, that just activates the cheat in my character class. And that just gives me all these inventory items here. So now that I've activated the cheat, my HP is 10,000. I have the most powerful weapon, which is the broadsword. I have the most powerful armor, which is the plate mail. And all the most powerful magic, like telekinetic force. And my magic energy is 10,000. So look at my inventory. I have all the inventory items. I have all the magic abilities. And I'm just cheating because I want to show you, I want to quickly dispatch some foes and show you how to save the game state, or what happens when we save the game state, okay? So, let's see. We've defeated a giant and we've defeated a dragon so far. So, west one, I'm going to go east to center one, and then I'm going to go north. I'm going to go south, and I'm going to go into the Shaman head. Okay, now I'm instantiating a Shaman object, which inherits from character, which inherits from entity. So you see that in the constructor clause there. And my options are, so here I'm just going to have a conversation with our NPC. This is our non-player character, right? So I'm going to choose to talk. I have a secret to tell, but I'll never tell it. And I can keep conversing with the Shaman if I want to. I can keep talking with the NPC. Sometimes I wish I'd never taken that vow of chastity. Ha ha ha. Good karma, bad karma, it's all the same. Or is it? Do you think I'm pretty? Don't judge a book by its cover. Beware the edge of the forest, giants are... But, you know, she will randomly drop some clues every now and then that the player may find useful as a reward for engaging in conversation with the NPC. And by the way, you never want to steal her medicine bag. If you do, it's pretty much instantaneous death. But we'll choose to leave. And now we're back in South 1. Okay? And we can go east. See a window, we can go west, and we find a healing potion. So that's, but because we used to cheat, we already had 5,000 of them. Let's continue to go south. We're in South 1. Let's go south again to South 2. And south, and are you sure I want to fight 3 giants all at the same time? And I'm going to say sure. Because I'm cheating. And the broadsword, it deals the greatest amount of damage. So which item do I wish to choose? I'm gonna switch from the longbow to the broadsword. Plate mail's plus 10 def, and I'm going to use telekinetic first for my magic item. Okay. So currently selected weapon is now the broadsword. Currently selected magic is now telekinetic force. I'm going to hit enter.
And we get locked into combat. And this will just go through and we'll see who wins. Zolt's entity attack sequence. So I'm the opponent and Zolt, in this case, he won the coin toss, he got first attack. But I'm a total cheater in this instance. So I slash with the broadsword and 29 random damage, and my combat attack skill, because I'm cheating, is 200, so it adds 200, and my weapon advantage is 20, excuse me. And then my magic subtracts an additional 40, so the result is gone. Okay. But remember, we're locked in a combat sequence with multiple giants. So that was Zolt, but now I have to fight Maruk. But again, it's okay because I'm cheating. 210, so we know that Maruk is right out of here. Carly's attack. So 28 random, our cheater level combat attack skills adds 200, and then 20 added by the weapon, and then minus 40 from the magic, so he's gone. Maruk has been defeated, and yet there's still one more giant, right? The 3 of them came at us at one time in this combat sequence, so Carly gets to look at the draw, and she gets the first attack in the coin toss. Alright, so a total of 241 damage, plus another minus 40 for our magic use, so it's safe to say that Leotel has been dispatched. He's been defeated. Okay.
Okay. So, again, because I'm cheating, we made it through that. Had I not been cheating, I'd most likely be dead by now. Look around, I'm in the South 2 location. Alright, now watch this. Let's save the player state. So, remember we defeated the giants, right? And so if I went south again, you see 3 dead giant carcasses, okay? So we need to make sure when we save that we save the game state and the character data. Additionally, let's look at our inventory. We have all these inventory items. Let's look at our magic abilities. And we have all these magic abilities, okay? So we want to call save and load. And I'll show you what I'm talking about. I'm going to call save game state, and when I do, it saves all my character data to a file called curly_character.csv. And it saves all my game state data to a file called curlygamestate.csv. And it's in the same folder that I'm running the script from. So let me see, where am I running this script from? Yeah, here and here. And actually, I was debugging that a while ago, so to show you what I'm talking about, I'm going to get rid of those files, and you can see them, you'll see them be created, okay? So watch again as I Okay, so I'm going to choose that option. I'm going to save character and watch those files now. All right, so these two files get created. Remember the code that we went over? So all of my character data got saved in this file. And if I highlight all those, all right, so this is all of my character data. And then the game state data is here. Okay. There. All right, so that's all the game state data that we had to save so far. Okay. I'm going to exit the game. Let me go ahead and options and quit the game. Okay. And I'm going to close PowerShell. And I'm going to reopen PowerShell just to make sure that everything's, initialized and fresh. And let's load. No, that's our GUI. We don't want our GUI there. Let's load the console portion. And that in the darkness. Okay. So I'm going to hit F5 and run it. And now I'm going to say load game. And it's going to read from these two files, the character data and the game state. Okay, so load game, enter to continue, save game files, curly character CSV, curly game state CSV, enter name of character. It's just displaying the files in this directory that match the criteria for being game files. So enter name of character to load. And I just enter curly. Okay, and that's good. If, I could have multiple players, and it would save. I would create a file based on that character's name for each character that I saved. So in this case, Carly, I load the data in for the character and for the game state from the CSVs. I hit enter to continue. Boom. Remember, that's the location we were at when we saved the game, right? And then remember we had already fought and defeated those dragons. Yeah, so if I go south, there I see 3 dead giant carcasses. Okay, so I successfully saved the game state. I don't have to fight those giants again. They were already defeated and I saved my progress. Now what about the character data like inventory and magic? Well, let's load up our options method. And in our options method, we're going to look at our inventory list and look, there's all our inventory items. Because remember we ran the cheat before we saved. And if I look at magic abilities, there's all our magic abilities, okay? And if I display stats, here's all my character data. So we successfully were able to save the character state and the game state to CSV files using the load and save function that we went over previously. And I'm just going to go ahead and quit again. And again, now that all of this logic is working in the console, if we want to, then we can go in and we can build an interface. Okay. Yeah. And just a graphical interface. And we're pretty much doing, we'll be moving our code to a graphical interface in later versions. So I hope you have fun with this. This is not something that, think of building a model. This is a pretty juicy long-term project. And if you commit to it, you can expect to work on this for weeks, if not months. Trying to code out your inheritance hierarchy, trying to code out your map, trying to code out your inventory, trying to code load and save. I'll give you my functions, I'll give you my code, but it won't do you any good, and it won't help you learn any PowerShell at all if you don't create your own. You understand what I'm saying? You need to take this project and make it your own. You need to own it. You need to do it your way and not my way. Don't copy my painting. Paint your own painting. But you can have this code as example code, and if you do this project, you will come out of it with a very firm understanding of everything we've talked about so far in all of these videos, all these PowerShell videos, because this project applies them all. It will give you practice with everything. And probably this is concluding the videos I'm going to do on console programming, on back-end stuff. I will eventually do a series of videos on graphical interfaces for PowerShell. And then I'm going to also do other things that are focused on like Exchange or Active Directory or security and compliance, SharePoint, different things that you manage in O365 and Exchange Online, or for your company when you're using Active Directory. Those are the things we really use PowerShell for. But these games and these projects, they were just a very agnostic and hopefully fun way to learn the language without having to get focus specifically on any one Microsoft technology.